this computer. So I hope you all had a chance to watch the video I sent an email about. That gave you a little bit of a further introduction to the scientific revolution, kind of extending what I talked about last time. Let me take volunteers before I get any further.
I volunteer, Professor.
Me too, sir.
Asma, Majd. Yeah. Who else?
Raymond's willing to volunteer.
Kareem has willing to volunteer.
Kareem. 1, 2, 3, 4, 5. One more. No, one
Zach,
more.
sir, I could volunteer.
Okay, Zach. All right, awesome. So last time we were, I was telling you, and this was basically my storyline here for this part of the course, which is that to set up the two thinkers we were talking about, and I did this also in the video, it's important to recognize that, you and I, we hear about this thing called the scientific revolution, or whatever this change was in the 16th and 17th century. And when we look back at it, it's I mean, a very good analogy here is, I don't know, what is a very good analogy? When you look at, if any of you have like a fruit tree, some of you have fruit trees, maybe orange trees, or you've seen them, or any tree whatsoever, or a flower. But I'm thinking about a fruit tree because I have an orange tree on my balcony here. As you watch it grow, you look at it every day, and as you're watching it, you clearly can say, right, that 3 weeks ago there were no flowers on that tree. Today there are small fruits on that tree. At one point there were no flowers, then there were flowers, and then there were small fruits. And that's clear, right? You look and there are little round fruits on the tree. They weren't there 3 weeks ago. Clearly, there weren't even flowers. But exactly the moment when that happened, I looked at it every single day, right? I couldn't tell you the exact moment when it went from having no flowers to having flowers. There's kind of a continuousness that's involved in that growth. That this is like with just about anything that's real and organic. You can take 2 moments in it and say, these are absolutely different. Something essential has changed. And yet, if you look at it at any moment, you can't really locate where anything essential changes. It's kind of one of the puzzles of the world that we live in. And it's just this way with organic things, but it's also this way with historical things.
But sir, I think it's more of a constant flow of change that keeps happening in the case of flower.
We think that, but the presumption one would have then is that the two things that are so different wouldn't really be essentially different, right? And we do think of them as like a tree with absolutely no fruit on it, has no fruit on it.
Yeah.
At some moment it had fruit, right? When was that? So from no fruit to fruit is a change from nothing to something, right? But none of those changes seem to be from that. That's the point. If you look at it on the whole, you can't really reconcile what you see with the process as a continuous change. You're right, it is continuous, perhaps.
But there also, I find this example pretty also similar to Descartes' wax example.
Maybe. There's somewhat of a similarity,
like
but I don't want... Go ahead, yeah.
It's two different things that go through different stages, but in the end it's the same matter that is in a constant flow of change.
So Maj just is pointing to an example in Descartes of wax changing its shape and color and smell, and it being the same thing because it's still wax. But this is a little bit different. Maybe a better example is the human being, right? We know at some point the fluids and things involved in reproduction are not a human being. But at some moment they become a human being. And you say, well, it's the moment of conception maybe, right? Where the egg and the sperm combine. But exactly when do they combine? If you look closer and closer and closer at them, you'll never find a moment where they go from uncombined to combined, right? You can only say that this moment earlier they were uncombined and this moment later they were combined. But exactly the moment that that happens, they're actually, you'll never find, right? Because there's no boundary called combining right here. You just see two things slowly merge. And the closer you look, the more continuous, but on the whole, it looks discontinuous. The scientific revolution is like this. Today seems fundamentally different from 1,000 years ago. 1800 seemed fundamentally different from 1300, right? 1500 seemed fundamentally different from 1400. But where things happened, whenever you would come up with an idea of what the scientific revolution is, like someone would say, well, this is the fundamental change. People started doing experiments, right? As soon as anyone says that, 100 people who study the history of science stand up and say, but look, there were experiments in ancient times, right? How can you say that's what made science different? And they say, okay, it's this. And as soon as you identify anything that seems to have never existed before, you'll always find cases where it exists, where it doesn't seem that science is there, right? So,
Professor, I just want to ask, how does us not being able to perceive that exact moment of, you just used that metaphor of like a tree that suddenly grows. How does it affect us keeping that progress going, especially in terms of the scientific revolution?
well, it affects us because we are thinking beings, and we try to understand and account for and justify the things that we do. And usually we do that by saying, well, this is why it's different, right? That's really fundamental, because that explanation, this is why science is also a recipe for what you should do to keep science going, right? And so people, once science, whatever it was, started happening, those fruits started showing up in the 16th century, people were very eager to know what happened, where's that moment? What is that fundamental change so we don't go back, right? The problem is people still haven't figured out to this day, right? But what's important is to have in your mind, that's what's going on with Descartes and Francis Bacon in the scientific revolution. They come late, they come after whatever was happening in all kinds of different ways. And they are retrospectively trying to formulate a clear recipe for how to do that thing called science, to spread it. So this is something now, like then it was very important because they thought it's only happening in isolated instances all over Europe. So how do we spread it to everyone, right? That's mainly what Bacon wanted to do, and Descartes in his own way. And so they came up with these ideas, right? And just as when you say, what's the difference between a tree with no fruit and a tree with fruit, or what makes a fruit, the little seeds are developing and so on in it. Those things that you isolate might have some truth to them, right? But they are almost certainly not going to capture the whole essence of what it is to be that thing, right? So Bacon and Descartes are going to look at particular examples of science going on in their period and raise those to kind of pure types, as if this is purely what you have to do and everything else is not science. We already saw, though, when we looked at Copernicus, that what was scientific in what he was doing was very unclear. Even now that we know science, we could look at things and say they're kind of scientific, they're kind of not scientific. They're at some weird intermediary phase. But that's where we still are, because we still don't know. There's things like string theory. You've probably all heard in quantum mechanics and so on, string theory. And there's a lot of scientists who say that's not a scientific theory. It's not a valid theory because it's not, for instance, testable. And then they have this idea of testability. The thing on the side of the string theorists is that a lot of science came about that before it was ever testable. So we're still not sure what really makes good for good science, right? And we're still having that debate and that argument. Well, the probably first really interesting such debate is between these two traditions I outlined in the lecture and I outlined last time, which I called the kind of the Cartesian, but the deductive tradition, right? The deductive rational tradition, and this kind of inductive experimental tradition, which is often represented as Bacon. And you should think of Descartes and Bacon as kind of mascots, right, for these two kinds of traditions, where there are, of course, people in the middle. Just to know, even not dualists versus materialists, there are lots of different dichotomies around, but this one is between the methods, right? There are ideas of scientific method. So here's a question. This is up from one of the quizzes. This is not the quiz that's up. And whoever answers these questions will get a little check mark if you answer it correctly. So first question, Descartes and Bacon are, I'll read the four and then take a volunteer to answer. A, advocates for the inductive and deductive methods in that order. Advocates for rationalism and empiricism in that order. Advocates for the deductive and inductive methods in that order. Or advocates for empiricism and rationalism in that order. If you need that a little larger. Shall I call on someone? Raymond, do you have an idea?
Professor, I would say
B.
B.
Yeah, B, sir.
B too.
Deductive and inductive methods in that order. Okay, so what is the deductive method?
Deductive method, it's basically you take something like it's like, I think about it in terms of math. So you take something that's like small and then you like deduce something like that's, no. You take something, yeah, exactly. So you take something that's like really general and you try to find a specific, apply it to a specific case which you are having problems with. And like inductive is like taking something small, like a natural number or something, and trying to make a generalization over all natural numbers or something like that.
Okay. So the most essential maybe characteristic of the deductive method is that, and Asma is spot on, the idea of the deductive method was generated in the process of the discovery of what's called mathematical proof. Right, so there's a famous geometer, Euclid, right? Ancient geometry, and he had this idea of trying to what's called build an axiomatic system where you have all the most basic statements and concepts at the top of your page, as it were, and then everything that's complex gets proven by some kind of a logical argument. So in deduction, we use premises and we apply logical arguments. And the idea of a logical argument is very simple. A logical argument, a valid argument, is an argument where essentially I can take premises and put them together in a certain way. And no matter what I do, if I follow the rules, what I make out of them will also be true if the premises are true. So logical rules are, you might say, they're truth preserving. So it's like a number of transformations I can do. I can have A is B, and I can do all kinds of stuff to that, right? And I can have all A's are B, and S is an A, and I can put one under the other and conclude from that S is B, right? all men are mortal, Socrates is a man, therefore Socrates is mortal. I took those first two things called premises, all men are mortal, Socrates is a man, and I combined them in a special way to get a new statement, Socrates is mortal, right? That's called modus ponens. That's one of the forms or transformations you can do on statements. And the essential idea is, if the premises are true and you follow logical rules, the conclusions must be true. So, because logical rules are logical if they are truth preserving, right? I can also negate and flip the things in a proposition, right? That's another transformation you can do. If you take the subject and your predicate and you negate them and change their places, that's, if the first statement was true, then that new statement will always be true. So deduction simply starts with premises. Its goal is to find those premises, right? First of all. So if you want to build a deductive system, the first thing you need to do is isolate the true premises, which are hopefully the simplest and unprovable ones, because everything provable you want to prove from something more basic, right? This is why it goes from those things that are most basic are more general, right? They're more general, like, for instance, in Euclid's geometry, you would prove, obviously, that a triangle has 180 degrees within its interior angles, right? If you take the angles of a triangle and you add them all together, you'll get 180 degrees, a Euclidean triangle. That's clearly something that's not obviously true. It requires proof. So you want to prove it from something that's more obviously true. What do you prove it from in Euclid's geometry? You prove it from the very idea of what a triangle is, as a three-sided planar figure. That's all you need. Definitions of lines, of points, and of the number 3. That's all you need. And you put those things together using logical rules, and you can prove that there's 180 degrees in there. Of course, you need some definition. You can't actually prove it's 180 degrees because you don't have degrees. That's a complicated thing. So what you really prove is that the interior angles are equal to 2 angles that are perpendicular, which is, we call that 90 degrees, right? 2 of those. You can prove that those are equivalent, that within the triangle there are 2 right angles. That's what you prove. So you need a definition of a right angle and so on. So that's deduction. Induction, Ozma said it somehow goes from the particular to the general. Induction you are all very, very familiar with, right? Children, you've been doing it since you were a child. You are mean to your brother and your mother smacks you. You're mean to your brother and your mother smacks you. You're mean to your brother and your hands go up, right? Because you're expecting that you're going to get smacked, because you have somehow formed the very basic inductive idea that if I am mean to my brother, I get smacked, right? I went from the particular instances, once, twice, to whenever I do X, Y will follow, right? You're going from particular to general. There's nothing new about induction, right? Aristotle talks about both deduction and induction. These were well-known ways of acquiring knowledge in the world. But we'll see that Descartes and Bacon have different ideas about which one of those are more primary in scientific practice, right? I said, someone asked if someone was a monist. Aristotle, Eva, no, he wasn't a monist. I won't go further into that. So why are these others false? Well, advocates of the inductive, this is just the reverse. Advocates for rationalism and empiricism. Raymond, would you tell us why that's not quite the best answer? Do you have any idea?
I think because maybe they weren't sure what you could find as empirical,
Okay, yeah, I think you're hitting it on there.
like that,
Yeah. This is a bit
like
of
they
a
were trying to
tricky,
define what empiricism was.
yeah. So empiricism is what complicates this question, and well, rationalism does too, in a way. Um, a good lesson for all of us is that when people educate us, they oversimplify things. I've said this before, and one of the ways they oversimplify things is they talk about, empiricism or rationalism or communism, or that we use these terms, which sometimes, like communism, well, I'm not even particular. I think that communism is actually used by the people who came up with the idea, but other terms is not the case. We've just created those because they seem to be useful. But often you'll find out that there's a weird underlying story that makes those things very unuseful, very deceptive, and so we should avoid them. And this is a very nice question where I was looking for the best answer, which is this one. Descartes is often called a rationalist. This is the idea that you use reason, and deduction is kind of the archetypal example of what it means to reason. Reasoning to reach conclusions in science. Of course, Bacon also used reason, so we're gonna have to see why Descartes is kind of properly called a rationalist. It's because he has a very extreme view on this. But empiricism is the problem, as Raymond pointed out. Empiricism, Bacon himself uses the term empiricism as a term to criticize people. He thinks the empiricists are stupid and crazy and wrong. This is unfortunate. Well, this is not unfortunate. What's unfortunate is if you go to Wikipedia and you read the article, if anyone wants to do that, they will find that Bacon is the father of empiricism. Right? That's what it will tell you. The word empiricism, this is one of these cases where the word empiricism as written today means something completely different from what it meant in the time of Bacon. In the time of Bacon, empiricism was applied to a certain group of people, particularly doctors, who relied on their personal experience to come up with ideas for how to cure people. Because they were not educated in the traditions of medicine, they were considered ridiculous people, the kind of people you would see on late night TV or something, who want to sell you a cure that they tried in their garage, and mixed together and said, oh, look, I gave it to my grandmother and it made her live forever, and so on, right? They're crackpots, quacks. That is what empiricism meant. And it started to be applied. Bacon took that term from medicine and started applying it to certain scientists who were, according to him, someone's phone is ringing, to certain scientists who he thought were crackpots. He called Gilbert, remember Gilbert, the guy with his ideas about magnetism, he called Gilbert an empiricist. And by calling Gilbert an empiricist, he meant he's a guy who has one or two crazy, experiences with a magnet and suddenly thinks everything is magnetic, right? He doesn't do carefully conducted experiments and careful, balanced, reasoned, inductions and so on. So for Bacon, in fact, says empiricism is worse than rationalism. And yet today, if any of you looked him up on Wikipedia, I'm sure you found him being called the father of empiricism, right? That's because in the last 100 years, less than 100 years, the term empiricism has changed its meaning. So sorry about that, but you always have to be careful with the way language is used here. So this is not a good example. And if you were reading just Bacon's text and not things like Wikipedia or taking philosophy courses, absolutely, will you take a philosophy course here? And I don't know who's going to teach it. If I'm not teaching it, they will say Bacon is an empiricist. They just will. They won't think about that because that's kind of the standard way that it's talked about, right? But I have to tell you that because you're reading the text, he's going to criticize empiricists and you're going to think, what in the world's going on? This is one of the things that happens when you read the primary texts, right? You find it's much more complicated than you would thought. Okay, so enough on that question. Advocates of empiricism, that's just the opposite order. Next question. Oh, well, I got to answer it here. Uh-oh. It took too long. I see what y'all are doing. Oh, I had to put my room name in. Hang on, sorry about this. Let's room name CVSP. Okay. Sorry about this. I didn't know that it would. Okay, here we go. The inductive experimental method does all of the following except it reasons from effects to causes. So inductive experimental. Reasons from effects to causes, reasons from particulars to general rules, reasons from wholes to parts, or reasons from principles to what follows from these principles.
D, professor. I think it's D. Am I right?
D. Anyone disagree?
Yeah, I'm also like leaning towards D. B also looks like an attractive choice, but I think
Yeah.
D.
Yeah. B. It's either B or D. I think. I don't know. I think it's
But
D.
B looks too obvious, so I'm just gonna go with D.
Zach, do you want to break the tie here? Or there's no tie, but
I have no clue, sir. Honestly, I'm with them both on on these choices.
Kareem, you got an idea? Guess he doesn't.
I think B and C are opposite answers, so you can't have both of them be true. So I would go with B.
I will break the tie. It is D. So how can it be both C and B? We have to understand this correctly, okay? There are two ideas that are quite similar to each other, but you should distinguish them in your mind. General to particular and particular to general, that is different from wholes and parts. So actually C and B are not opposites. Why is that? Well, the whole part relationship is different from the general particular relationship. Let me give you an example. One triangle is not a part of triangle as a general concept, right? Triangle, like the idea of triangle, of a triangular thing, is not made up of lots of triangles. They're not parts of it. The general idea of a triangle includes underneath it, we sometimes say, particular triangles, right? A particular triangle is an example of a triangle, but it's not part of triangle. You are an example of the general concept of humanity, but you are not part of the general concept of humanity. A red flower is red, but a red flower is not part of the concept of red. You see the difference between generals and particulars? Concept of red is general. A flower is a particular red thing, but a flower is not part of a whole thing called redness. These are different. It's an important distinction. So the inductive experimental method goes from the particular things we find in the world, right? And tries to arrive at their constituent, the things that make them what they are. A good example here, a television set. If you were to apply the inductive experimental method to a television set, say you are an alien species, you've never seen a television. Probably many of you, maybe some of you have never seen a television because people don't need them these days. But if you were to find a television and you didn't even know what electronic things were, it just fell out of the sky, how would you understand it? Well, you would start to take it apart, right? Maybe even it's got a battery in it, so you push a button and it turns on, and you want to understand it. Well, if you were an intelligent alien, you would start taking it apart, right? You would try to understand its parts. You would take it into its electronic components. You'd have, resistors and transistors and maybe some, kind of chips and wires and a tube and all these kinds of things. And you would take those things apart and you'd say, okay, the TV has these parts. Now you would have to go another step, right? Maybe you'd have to look at several TVs, but you wouldn't need to in this case. You'd start to sort all the parts, right? And you'd find there are all these things with little colored bands on them. You'd put them away and you'd study them and you'd find they all have little coils of wire in them that are really, really long, just all scrunched up. And that when you put electricity through them, electrons through them, less of the electrons kind of get through certain ones than others. And you find out, okay, this thing in the TV has the role of kind of choking and stopping electrons from flowing, right? So those are resistors. And then you would look at transistors and you try to understand all the parts, right? But of course, if you really wanted to understand it, you'd have to go deeper. So you'd go from televisions, this television, to resistors, transistors. Notice these are already more general, right? Transistors are in all kinds of objects, resistors in all kinds of electronic objects. But then you would have to study how electrons work, how conductivity works, right? The basic laws of electrical things, how alternating current works, right? This is quite complicated still. But then you'd have to go even deeper, right? You'd want to go down and understand subatomic particles, how they're generated, and so on. And as you got deeper, you would be going from things that are specific to things that are more general. Eventually, you would just have to study the electron, right? And the basic laws of electromagnetism. These become more and more general, right? So I go from specific things given an experience, and I proceed towards now the things that are more basic, but are also more general, right? Also, at the same time, I'm going from what is an effect. The television turning on is the effect of the transistors and the resistors and so on. And the way the transistors and resistors operate is an effect of the way electricity works. And the way electricity works is an effect of the way atoms are structured and the way electrons behave and so on, right? So as I go in this process, I'm going from effects to causes, right? At the same time. So, so the inductive experimental method goes from effects to causes, from particulars, the TV that I find in the world, and everything I find in the world around me are just individual objects, right? They're particulars. So I go from particulars to the general rules governing those particulars. I go from wholes, the TV is a whole thing, to its parts, to its components, right? I start with a whole triangle in Euclidean geometry, and I trace it back to its parts, right? Lines and angles and so on.
Professor?
But, yeah, yes, Andre?
So is it like saying, for example, if P equals Q, then it would be something like Q implies P?
Can you say that again?
If P implies Q, as in TV implies that you have this functionality, this set of components, everything, then what you're saying here is kind of the reverse, going from Q to P.
Yes, it does go in the opposite direction of a deductive argument, as you're saying.
Okay.
Of course, it only goes in. You can't. That is one way to think about induction. It goes in the opposite direction of deduction. But on the other hand, deduction is only valid, really, right? So deduction is truth preserving. Induction is not necessarily truth preserving. So if I might go from my mother slapping me when I annoy my brother to mothers slap their children when they annoy their brothers. And then I go to a party and I see my friend annoying his brother and his mother doesn't slap him, right? But I say, hey, you have to. She says, no, I don't. That's not a logical argument. That's induction. And your induction was bad, right? Because we only ever see particular cases. So when we make the leap from the particular to the general, we're always taking a risk, right? We're always possibly in error. Whereas if we start with premises that are true and we apply logical rules, the very idea of a logical rule is I cannot be in error. So there's something more certain and secure about deduction than induction, right? Although they are in opposite directions, that does not mean that you can go both directions in the same way and following the same rules. We're still trying to figure out what the rules of induction are, but we've known what the rules of deduction are for quite a while. So reasons from principles to what follows from these principles. The original meaning of the term principle, principia, just means a source or a beginning of something. That sounds like a technical word, right? Principle, but it just means the beginning or starting point of something. Reasons from principles to what follows from these principles. No, that's what deduction does. It starts from the very roots or sources from which things come. So for instance, triangles come from the combination of lines in a certain way. So deduction starts with lines and proceeds to more complex things. Whereas inductive experimental method actually starts with the things that follow from the principles and try to find the principles, right? So, good, we didn't spend too much time there. The deductive method does all of the following except deductive. Reasons from wholes to parts, from principles to what follows from these principles, reasons from causes to effects, or reasons from generals to particulars. Andre, do you have an answer for us?
Let me recheck. It's the second one.
I think B.
Yeah, B.
From causes to effects. What do you think?
I think so. I think so.
So it doesn't. You're saying it doesn't reason from causes to effects.
That is correct.
Well, let's check the others.
Sir, I
Reasons
think A.
from wholes to parts.
Professor, I think it's A.
Maj thinks it's A. Why do you think it's A? Why do you think that they're wrong?
Because in the previous question, we were talking about inductive methods that does everything except, and we were talking about how wholes and parts can be a deductive, can be inductive, but not. We were explaining that point from the last question. Therefore, I think it does not fit here.
So Majd is using a little bit of
Controversial thinking in a way.
quiz logic.
Yeah.
to say he's
Can I-
studying the SAT
No, but
textbooks.
actually makes sense because in logic, we cannot think that a deductive argument doesn't go from, no, it does not apply. It can't be an argument that reasons from wholes to parts.
I don't
Yeah.
know what you said, but can I counter what he said?
Sure.
Well, if you wanted to specify something for the part, you'd have to establish it for the whole. That's why it would be proof for the part, because the part would be a part of the whole. For example, if you wanted to back up your statement that Majd isn't special because he has 2 legs, then you'd go to the whole. Majd is a human. Humans have 2 legs. Therefore, Majd isn't special since he has 2 legs. So
Yeah.
that's like kind of going whole to part. So sorry, Majd, you've been served.
Yeah, I have
So-
been, I think.
So Karim, but, and this was this key, this is why language is important. We need to preserve certain kinds of distinctions. The whole, what you're calling the whole is not the whole. What you're calling the whole is the general.
That's how I understood
the
what.
general.
Okay.
So we need to distinguish
Yeah.
wholes from generals. A whole thing is a thing with all of its parts, right? So a whole has a part relationship, whole part. Now, Majd is not part of the general concept of humanity. He's not. If I destroy Majd, I do not destroy part of the concept of humanity.
So there isn't a causal relationship here, right?
But if I destroy Majd, he is a part of his family, for instance, because the concept of a family is not a general concept. It's a collection of things, right? So I destroy part of Majd's family if I destroy him, but I don't destroy, just as if I said a triangle is not part. So this triangle that I'm drawing, there it is. I don't know if you can see it. Probably not. There we go. That triangle is not part of triangularity.
Okay.
What's within triangularity? It might have parts, but it's like, I don't know, whatever's in the definition of a triangle. Those are the parts of what it is to be a triangle. So that's important. There's a distinction between the general and the particular.
Okay.
So a whole is kind of like a set, and a part is like an element of the set.
Yes, exactly. So a part of a television is not another television, right? It's a resistor, right?
Yeah.
So that's the idea. So, but we can go here. B, reasons from causes to effects. Remember, we said induction goes from effects to causes, right?
This is actually why I thought, and it's not B.
Yeah, I mean, B, deduction goes from the causes to the effects. So as I said, when we look at a television set, we might, if we wanted to go from the very beginning, we would start from the very principles of electromagnetism, perhaps, right? Maybe even more. And those are the causes or reasons why electrons move in a certain way. And those are reasons why resistors act in certain ways and transistors act in certain ways. And that's why televisions work in certain ways, right? So that's the deductive way. We go from the very beginning to the way this particular thing operates, and we show the reasons why, the causes, why it, as an effect, happens in a certain way. So the answer should be reasons from wholes to parts. According to Descartes, Aristotle is out of fashion, is the greatest of all philosophers, has the right method but does not apply it, is too empirical and relies too much on the senses. What do we think?
I would say D.
B?
D.
D. And why would you say that?
Basically Descartes. So basically, I picked it from the second part, which is relying too much on the senses, and that's something that Descartes, I believe, is not a big fan of.
Okay. Okay. So as Asma's saying, we're going to see Descartes is like he's going to look at science and what's going on, and he's going to see a special form of the deductive method as being the essential element of science, right? And what happens, this is just very typical modern, but it's all over, right? You need to have enemies. And it's, this is just the way the world works. When someone wants to make a revolutionary change, they think, and explain what they are doing, they need to find someone who's counter to them. And it's very unfortunate if you counter many things, but each person has different, like you don't have one enemy, you've got lots of enemies, right? It's better if you can like put all your enemies and bad things in one character as kind of the person you talk against. And so what's interesting is this causes people like Descartes and others, when they're criticizing others, never take their word for it, right? They're painting an image of that person to serve their own purposes, right? And we see this nowhere more clearly than in Descartes and in Bacon, because both of them, as representatives of the modern world and against traditional education, the church, and so on, at least in its traditional form, although Descartes was very much a Catholic and part of the Catholic Church, we'll find they dislike Aristotle. Their enemies in the schools are Aristotelians, right? So they're going to paint Aristotle the way they, in a way that's opposed to what they think. So Descartes, being this rationalist, using the deductive method, regards Aristotle as D, too empirical, relying too much on the senses. In other words, what we're going to see, Descartes regards Aristotle as much like Bacon, right? Which is funny, because Bacon will regard Aristotle differently as well. This is interesting, but this is part of that whole tradition. Galileo, in his book on the two chief world systems, has a discussion with an Aristotelian. And the Aristotelian is too empirical. And he uses a principle that is from Aristotle, right? Which is that when you're arguing about something, the final say should be had by the senses. And so they're arguing about whether Copernicus is correct, right? Whether the earth moves. And the Aristotelian says, look, empiricism, right? I'm not moving. There's nothing more obviously true. So no matter how complicated our arguments get, we cannot lose sight of this fundamental rule that we should always trust our senses, right? And from Galileo's point of view and Descartes' point of view, that person is stupid. They don't have the imagination to think beyond their own experience and to think that their own experience might be the effect of some very complicated thing going on that has tricked them, right? So you shouldn't trust your senses, according to Descartes. Your senses are deceptive. When you look in a glass of water and put a pen in it, the pen will look broken because of the refractive index of the water. Don't trust your senses. If it rains and you look up in the sky, you will see a band of colors, perhaps. There is no band of colors, right? Out in the sky. That's just an illusion created by the light being bent through the raindrops, right? So perceptual illusions are things that we need to use logical reasoning to solve those problems, according to Descartes and so on. So too empirical and relies too much on the senses. According to Bacon, Aristotle is the greatest of all philosophers. No. Should have been a cook instead of a philosopher, is too rationalistic and does not use the senses enough, or is too empirical and relies too much on the senses? I think you all know now the answer is C, right? So Bacon, read him carefully, Aristotle is too rationalist. The exact opposite of what Descartes will say, right? And he'll point to those things. If you read Stephen Hawking's Brief History of Time, chapter 1, he will talk about Aristotle as being too rationalistic. That's weird. Why is that? Because although Stephen Hawking was a very theoretically minded individual, he occupied the Newton's chair, right, at the university, and he thinks of himself in the great tradition of British empiricism. And so for him, Aristotle and all ancient philosophers didn't do enough experimentation and were too rationalistic. So you see, it's not just Bacon and Descartes that will have these prejudices that influence the way they interpret previous thinkers. Someone like Stephen Hawking still perpetuates the same kind of ideas today, right? Just an example. Okay. Okay, we almost did well. Anyone say anything in the, oh, don't want to do that. Chat. Let's see. Descartes, I think she's talking about Descartes. Eva says he was a skeptic. No. The only true and infallible truth is the idea of knowing that you're thinking. No, we got to be careful. We're going to read Descartes later, Eva, and you'll find that many of the things you may have heard about Descartes just aren't true. He wasn't a skeptic, first of all. He was exactly the opposite of a skeptic. But we will see he uses something called the skeptical method, but he's not a skeptic. And no, he didn't. He didn't think the only thing we know is that we are thinking. That is the first thing that we find out is true, but we find out that all kinds of other stuff is true, right? All of science becomes certain, and we know about the entire universe, according to Descartes. This is another reason why he's not a skeptic, right? Skeptics claim that you can't be certain of anything. Descartes thinks we can be certain of just about everything, right? Except for certain things that we should avoid. Okay, so let's look at any questions? Let me see here. So I think I assigned maybe the first 10
questions.
days. Yeah, go ahead. Go ahead, Majd.
So I just want to tell you that I don't have questions, but I just want to say that the music in the background is very soothing.
My son is practicing. Yeah, sorry about that.
He's getting good.
It was violin last time, wasn't it?
What? It was violin last time, yes. I have 4 sons. 2 of them play piano, 1 of them does classical guitar, and the other one does violin. So lots of noise and some music.
So yeah, I assume you have a band at home, sir.
What?
Right? I assume you have a band at home.
Yeah, something like that. So let's talk about Francis Bacon. First of all, just some general things about Bacon, right? He lived from 1561 to 1623. We saw, this is pretty early still, right? We saw Bruno was executed in 1600. Copernicus died in 1543. Galileo will be condemned in about this period at the end of, just after, I believe Bacon died. We'll see Descartes is a little bit later. Bacon is, an enormous figure in the history of British science and philosophy. He's not read as much anymore. If you take a modern philosophy class, you may not read Bacon at all. That's because we tend to focus on other things today. He was in the British government. He in fact got towards the end of his life. He lived a pretty normal life of a civil servant, except that he was quite creative. He wrote a lot of essays, on death, on cannibalism, on different kinds of topics, on honor. That was actually one of the first, kind of philosophy style books I read as a young man, a young boy, was the Essays of Francis Bacon. But he also, that's one thing he did. He's also, there was a period of time where some people thought that he might have been who Shakespeare was. Ben Shakespeare wrote the plays that we attribute to Shakespeare. That's not true. It's kind of a ridiculous view now, because we have more than enough evidence to prove Shakespeare really existed and he wasn't Francis Bacon. But this is the kind of writer he was. He also, one of his key things was advocating for science. Why was this important? Well, as I've told you before, science, it took place in the church to some extent. So if you go back and you look at the medieval period, there were what we would call scientists, people working on things like optics or so on. There were some people in the church. There was people outside of the church, a lot more of them coming along. If you look at the tradition within the church, it's very rare. In the 1300s, there was a guy. In the 1100s, there was some guy, right? There was like one isolated individual, and they undertook science as kind of just because that's the kind of personality they had. They were good at mathematics and they were interested in nature. And it was just these isolated events, right? Until, as we've seen in the 16th century, things started happening outside of the church, and there started to be a lot of people working on these things. Now, still, even though that was happening, that's happening outside of any kind of institution. There were in the 14th century and through most of the 15th century or all of the 15th century and most of the 16th century, there were no scientific institutions whatsoever. There's no individual institution devoted to science. Nor were there any government institutions devoted to science. So in the medieval period, the idea of a government, right, was of someone who has the rights over a bit of land, and they have no duties to the people, right? So rulers in the medieval period, if they improved the world, the roads, the water systems, and so on, they did it basically almost exclusively to increase their own power by making their societies stronger, right? So there was never this idea that the role of a ruler is actually to serve his own people. As soon as that starts to change, though, and we'll see particularly in political science, this will change. The question is, how do rulers serve their people properly, right? Even what does it mean to serve the people properly? Well, it's improving technology is one of the major features, right? We could have a lesson here in that in Lebanon, right? Creating an electric grid and so on, so that people can live a decent life and healthy and so on. So Bacon was one of the absolutely instrumental in bringing that change about, trying to convince the British government, in particular the English government, that they should invest in science, that science is a function of the state, that it's for the people's good. So first you need the idea that the state is for the people's good. That's a rather new idea, and not for the king's good. And then you need to convince them that that good can be achieved through science, and that we need to bring all these people who are working in the margins and outside of institutions into institutions where they can freely and with good monetary support investigate nature, right? This Bacon kind of created this whole idea from the ground up.
Professor?
Yes, Andre.
But what you said previously about improving themselves over for the people is still largely true today, because For example, if you take if there's a road that's dangerous, and somebody comes to fix it, what they will do first is evaluate, for example, kind of the GDP of the people using this route, and then evaluating how many people die each year on this road, and then if it's not feasible to fix it because facing the requirements of money and stuff like that, they just won't fix it, right?
Maybe it depends on who and where and what you're talking about. It depends on the individual case, but in general, I think you would agree that we generally hold it to be a function of the government to help regulate life for the benefit of its citizens, right? You think so?
Yeah, maybe.
Yeah, maybe. In fact, that's our default option. And then we see, well, people don't all do that, right? Like there are certain people in Lebanon and other countries that are trying to exploit the system. But for us, that is an outrage. That's not what the government is for, right? It's to serve the people. Well, in the medieval period and in the early modern period, it was the exact opposite, right? Like the guy who would be a ruler who would do something selflessly to help his people would be considered an idiot, right? It's like people who lavish too much luxury on their pets. That's how it would seem, right? Because just for you, you are the master. Why would you serve them? Well, now, and so science is absolutely part of that. Every government that you can, every developed government funds science in some way, right? Or feels that it should, and if it had more money, would fund science, support science, regulate, supports universities and education and all this kinds of stuff. Originally, and because of Bacon, there was created this thing called the Royal Society. If you go on YouTube, you can actually, there's a whole video series a guy does about the history of the Royal Society and various objects and things. You'll find there that the British that created this thing, right? Funded by the government, where people would become members of the Royal Society. It was a very prestigious thing. They would come and they would read out reports of their scientific discoveries, right? And they would be published in a journal, a special journal, the Acts of the Royal Academy. That was the first journal, scientific journal, that ever existed. The idea of a journal was, today, if you do science, journals are one of the central parts of your existence, because one of the key instruments of science is peer review, right? Reviewing each other's results, testing, retesting, criticizing. There's a part of modern science is this community of cooperation, of mutual exchange, right? And so that, of course, didn't exist in the medieval period. That didn't exist in the early modern period. Copernicus had no, 3 people he could write a letter to or something, right? There was no journals. There was no way he could publish and get his results, evaluated by peers or anything like that. That whole idea was, again, something generated and created by Bacon as part of his kind of fantasy about what a future scientifically minded society in which the government funds science could be like. So this is what he advocated for. He was not a scientist. He was a visionary of science as an institution, right? As a cooperative societal thing. And that is not super exciting in a certain sense, but on the other hand, it's probably one of the most important changes that took place that makes science today, right? Is this process by which results are criticized and published and so on. So after Bacon, they created the Royal Society. Bacon is their kind of hero. There's a bust. If you look at the acts of the Royal Society, they still have there's a bust there of Bacon. Then there's created the French Academy of the Sciences. Some of you have heard of this. This was following the model of the British Academy. There's the Berlin Academy in what was Prussia, but is now Germany, right? These academies slowly spread all across Europe as the governments, following the British example, created and started to fund science, and each one of them created its own journal. And this is how that aspect of science, we don't often think about it all that much, how important it is. But without it, there wouldn't be science. So towards the end of his life, Bacon, he seemed like, we're going to see he really speaks as if he's a benefactor of humanity. But late in his life, he was kind of caught embezzling money in the government and got put in jail. So yeah, so our heroes. This is so he wrote, so he's just a writer, not so much a scientist. I said a visionary trying to depict for us and to explain to us what makes science science and how to turn that into a reliable process, institutionalized process, right? This is his main idea. He does this in a major work which was never completed, called the New Organ, or the Great Instauration, the Great Renewal, it's sometimes called. And this is the book, the cover. You can't see the whole thing here, of the Instauratio Magna, the Great Renewal or Great Instauration. Consisted of several books, as we're going to see. He only wrote some of those books, or completed them. So here's the picture. Now, this is called a frontispiece, right? It's what you'd find printed at the beginning of the book, published in 1620. Sometimes when you open up old books, a lot of them have really nice pictures in the beginning. Most of those, however, have nothing to do with the book. They are just, for instance, the printer's picture. So certain publishers like Cambridge University Press or whatever would have their own picture. But sometimes, in particular cases, people had their own frontispiece designed for their book. And Bacon did. So this is a symbolic representation that Bacon himself devised to kind of give you a sense of what he's all about, what the Great Instauration is about. Does someone want to tell us what's happening in this picture? What do you see?
I'm kind of confused because this is supposed to be the sea, but we have these tall, I don't know what they're called.
Pillars?
But it kind of reminds me of a metaphor he used in his text when he was talking about the monsters in the sea, that myth, where you have like in ancient, I think in ancient like Greece or something, there was in a place in the sea, whenever sailors need to pass through the specific place, they're surrounded by monsters from like two different sides, so they have to be careful.
Yeah.
Not to like, yeah, exactly.
Was someone in the chat? Scylla and Charybdis. Okay, so he uses, Bacon uses a lot of, we're going to see this, a lot of sailing metaphors. But obviously this is, think about it, compare with Bruno, for instance. There's something about discovery, right? This is supposed to bring to mind Columbus, discovery of the New World, and so on. Now, what are these pillars? There were, you've heard of these things, the ancient wonders of the world. These monuments and things that belong to the ancient world that have been remembered. One of those monuments that no longer exists was called the Pillars of Hercules, or the Pillars of Heracles, same person, right? These were supposedly pillars that marked the end of the known world. And you should never go beyond them. So in ancient times, sailing was not a very exact science. So if you went out like this, like straight out to sea, you're probably not coming back. Most people, the ancient Greeks and so on, they followed the coasts. Because the coasts, you could see stuff and you could get off if you have trouble. So they would generally follow the coasts or places they knew. You didn't just sail out into the Atlantic Ocean, right? Because you're not going to come back. You're going to get lost. You're going to starve to death. No one knows what's out there. Danger, right? Risk taking. So these pillars were supposed to mark kind of the edge of the known world. And for the ancients, that meant you don't go past them. Well, obviously there's a ship out here and there's another ship following it. That is what Columbus did, right? He just sailed, crazy as he was. He heard some stories about that, you could get to India by going into the Atlantic Ocean, which was not true, right? And he, luckily for him, stumbled upon some land in South America, which he thought was India, right? That's why they call them Indians. Even today, sometimes people in North America and so on were called Indians because he thought he landed in India. So Bacon is taking that example of Columbus positively, unlike Bruno, who saw a very negative idea, of discovery, exploration, the daring involved. And this is his image for science. Science should, like Columbus, extend our knowledge to a new world. And underneath he says, many will follow, in Latin, and science will grow. Right? So it's not just one little ship out there. It's not just Bacon on his ship. He wants it to be an example, right? Just as Columbus went to the New World, but after him, a whole series of people came and discovered new parts of North and South America, right? Many followed, and the wealth of Europe increased. Well, here, many will follow, and science itself will increase. So this just shows you the kind of what he believes the new organon will do. It will provide an inspiration and a guide for others to discover the world, right? And take that risk. So that's the frontispiece to the Great Renewal. And we're at 2:17, so we'll continue Bacon on Thursday. Any comments, questions?
Thank you, Professor.
Thank you.
Thank you. Hope
Thank
you all stay safe and
Professor.
Sir.
Thank you, sir. You too.
Goodbye. Stay safe.
yeah, you too.